So in this video, we're going to look at how to get the area between two curves, okay? So we're actually going to use the same method as we used in the last few videos. This is going to be a little trick so we can calculate the area, say, in this region here, okay? So the way we're going to do it is first we're going to calculate the area under the red curve, okay? So I'll shade that in red, so between, oh, no, that's green. Let's go back to red. So go straight down here, okay? So the area under the red curve is going to be shaded in red there, okay? So I'm not shaded very well, but you get the idea, okay? So that's the area under the red curve. Now the area under the green curve is this bit here. So if you take the green area away from the red area, you're left with, I don't know, I'll do purple, which is the area that we wanted in the first place. Does that make sense? So basically, that's the method we're going to do. We're going to calculate the area under the red curve, calculate the area under the green line, take them away, and we're going to be left with the area in between them. So that's the whole method that we're going to do. Now we're going to look at an example at how to do that. Okay, so I just got rid of some of the scribbles I've done there, and here's our example question we're going to do. So again, we have the same curve here, and it's y is equal to minus x squared plus 5x minus 4. We have this green line here, which is y is equal to x minus 1. And the question is, find the area between the two curves. So that's this area here, if we will. Okay, so if we want to calculate that area, there are two things we need. We need the limits of integration. So we need that point, and we need that point. Okay, so the way we're going to calculate this point here is we're going to find where this curve, the red curve, hits the x-axis. Okay, so if we find where it hits the x-axis, we're going to find this point and this point. We can just neglect this point because we already need it. This is the one that we want. Okay, so that's the first thing I'm going to do, because it's all about, like, the whole trick about this is being able to find the limits of integration. Then all you need to do is just integrate the green, integrate the red, and take them away. So now that sounds kind of confusing when I talk through it all like that, but when we go through it in this video, it shouldn't be too bad. So the first thing is you need to find your limits of integration. So these 2 points here and the x-axis. So like I said, we're going to do this by solving the quadratic. So I'll go to orange and I'll solve this quadratic. So it's going to be minus x squared plus 5x minus 4 is equal to 0. I'm just going to multiply everything by minus 1, so change that to x squared minus 5x plus 4 is equal to 0. Then I'm going to stick the brackets in. Okay, it's going to be x minus 1 and x minus 4 is equal to 0. So that means that x is equal to 1 or, let's go back a little bit, x is equal to 4. So the one we want is obviously going to be x is equal to 1 because it's on this side. So that means that value there is 1. There we go. Okay? Yeah, 1. So now we need to find this one here. So the way to calculate that is follow this red dashed line up. This is the place where the green line and the red curve connect. It's where they bump into each other. Okay? So we're going to have to solve that with simultaneous equations. If you remember back to algebra, if you wanted to find the point where two lines meet, or a line and a curve meet, you have to use simultaneous equations. Okay? So I'll do that in, I guess, light blue, and I'll just do it on this side. Hopefully we'll be able to squeeze it in. Okay, so we have that. I'm just going to close this off. Y is equal to x minus 1, and also that y is equal to minus x squared plus 5x minus 4. So if we want to let them equal to each other, see they're both equal to y. Okay, so that means we can say that x minus 1 is equal to minus x squared plus 5x minus 4 in. Okay, so if we solve this now, so we let them equal to each other, if we solve this, then we can find the point where they interact or where they intersect. Okay, and then that'll give us this x coordinate here. So just rearrange this. It's going to be minus x squared plus 4x minus 3 is equal to 0. Multiply by minus 1, we're going to get x squared minus 4x plus 3 is equal to 0. So if you want to just get a refresher on that, they're going to be back in our algebra videos about simultaneous equations, the one quadratic and one linear. Okay, so that's how to find where 2 points, where two curves, or a curve and a line intersect. And I'm just going to run through. That's going to be x minus 3 and x minus 1 equal to 0, and that means x is equal to 3 and x is equal to 1, and that's going to be our other point here, then x is equal to 3. Okay, so now that we have our limits of integration, we can go about starting to actually integrate this thing. So the first one I'm going to integrate is the green one. Okay, so if we integrate the green line, we're going to find the area there that I just kind of pretended to shade, so the area under the curve, or under the line I mean, sorry. Okay, do that first. It doesn't really matter which order you do them in, so I'm going to write this out. So it's going to be area is equal to the integration. Remember, the limits of integration are 1 and 3, and the line is x minus 1 dx. Okay, so I'm going to go ahead and do that. That's going to be square bracket x squared over 2 minus x 3 and 1, which is going to be, so there should be a circular bracket. I'm going to do 3 squared over 2 minus 3 minus 1 squared over 2 minus 1. That's 3 over 2 minus 1 over 2, which is just equal to 2. Okay, so that's the area under the green line. So now we're going to get the area under the red curve between 1 and 3. So I'll go ahead and do that in red. I'm going to say now that area is equal to between 1 and 3 of minus x squared plus 5x minus 4 dx. Okay, I'm going to go ahead and integrate that. So that's going to be square brackets minus x cubed over 3 plus 5x squared over 2 minus 4x, evaluated from 1 to 3. Scroll down a little bit more. It's going to be minus 3 cubed over 3 plus 5 by 3 squared over 2 minus 4 by 3, close the bracket, minus 1 cubed over 3 plus 5 by minus 1 squared over 2 minus 4 by minus 1. Okay, so it's a little bit messy, a little bit long. This then is going to be equal to, sorry, I just realized I made a big mistake there. That shouldn't be minus 1, that should be plus 1 and plus 1. Sorry about that. So it's 1 and 3, so it's going to be sub 3 into all of these minus sub plus 1 into all of these. Sorry, I changed all of that. Sorry about any confusion there. So anyway, I'll just finish off the sum then. So you stick that into your calculator, and you get this bracket is 3 over 2 minus this bracket is minus 11 over 6. So the overall answer is 10 over 3. Okay, so that's the area under the red curve. Okay, so now if we want to find our purple area, our final answer, is there any space? Okay, I'm going to do it in this box here. So I probably should make more space, but let's try and keep it on the one page. Sorry about that. So that means we'll say our purple area is equal to, I'm going to say, red area minus our green area. Does that make sense? So I'd always recommend calculating each area separately and then at the end sticking it into one line like that. Some people do the whole thing in one big line, so they say the purple area is equal to this integration minus this integration, but then I think that just gets really messy because you end up with 4 or 5 different brackets all in one line. It's much simpler if you do each one individually and then at the end you just take the numbers away from each other. Whichever one works for you, but I think this really is just a better way of not getting confused anyway. So the purple area, I'm just going to say A is equal to, so the red, which is 10 over 3, minus the green area, which is 2. Okay, so our final area between the curves is equal to 4 over 3 units squared. I'll say units squared. Okay, so does that all make sense? So sorry about that purple mess at the end there, but the whole idea is, again, this is the most important bit of the video, is that if you want to calculate the area between two curves, okay, you have to get the area, say, of the bigger curve, the red one here, between the red and the x-axis, and then the area of the green, of the curve, or sorry, the area between the green line and the x-axis. Take them away from each other and you'll get the remaining area there. Okay, so sorry about that last explanation. I don't know if it made loads of sense, but that's basically the hardest question you're going to see. So they can ask that in loads of different ways, but that's the basics of it. You need to find your limits of integration, find one area, find the other area, take them away from each other, and you'll be left with your area in between the two curves. So hopefully that made sense. The next video should be our last video on integration. We're going to talk about the average value of a function, which comes up quite a lot.